When you look at data graphically, one of the things that you'll be able to do is describe or give a description of the data distribution, how the data is appearing to be spread out or where the center of the data is. And those are the two things that we're going to look at, measuring the center and measuring the variability. So let's look at some examples. Okay, this is a dot plot, and let's say this is the temperatures in your city in the past couple of weeks here. What you can see is each dot represents, let's say, the high temperature on each day. And so you can see that there are several dots here, each one for each day, and you can see that they're at several temperatures here. For instance, two of the days, the high temperature was 66. On 3 of the days, the high temperature was 70. So you get the idea. Well, one of the things when you lay out the data like this, instead of just a big list of numbers, you can start to see some different things about the data. For instance, what is the approximate middle temperature? Well, you will learn how to calculate different measures of the middle, but you can just see from this graph that somewhere here in this range, maybe 68 or 69 degrees, was the approximate middle temperature. And you can just see that from the graph, and that's one of the great things about graphs. Let's look at another example here. This is called a histogram. So it's like a dot plot. You can see that it kind of spreads out the data over different numbers that were gathered in a survey or in gathering data like temperature. In this case, we're looking at hours watching videos per week. And with the histogram, you put the data in ranges. So unlike a dot plot where 66 and 67 and 68 are broken out like that, here if there's 11 or 12 or 13, it'll go in this range right here, 10 through 15, and you don't see the 11 and the 12 and the 13. You just see that there was a bunch of data points, it looks like 10, actually you can read here on the axis, that were in the range of 10 to 15. So histograms put the data into ranges. A lot of times this makes it a little bit easier to see the distribution of the data and also the center. And so we can ask ourselves the same question, what is the approximate middle range? Well, we can see that probably most of the temperatures or the middle of the data is somewhere here in the 15 to 20 range. And you can just see that from a histogram. Let's look at another example. Here's another dot plot of temperatures. And we can ask ourselves, what is the interesting thing about this data set? Well, you can see that unlike the other data set here, where everything was kind of clustered around some sort of middle, you have some data points that were clustered, but then you have this data point that's sticking way out here, clear down at 40 degrees. That's called something like an outlier, okay? There are technical definitions of what an outlier is, but for now, just understand that there's a data point that seems to be far away from most of the other data points. You can think of that as an outlier, and that's a really interesting thing. In other words, in this case, there was a really cold day. Okay. Now let's look over at the variability. So the center is kind of where the middle of the data is. The variability is how the data are spread out. And so let's go ahead and take a look at the temperatures in 3 cities here. We have city A, city B, and city C. And you can see that there's kind of a different distribution in each one of these cities for the temperature. So let's ask ourselves a few different questions here. First, what is the approximate middle temperature for city A? Well, you can probably say, it looks like it's somewhere right around in the 59 degree range. Okay. Now, what about for city B? Well, that's a harder question. It seems like the middle of the day would be around here, but there are actually no temperatures in that middle area. What we think of is that city B kind of has 2 middles. We call that bimodal. One middle around 95 degrees and one middle around 100 degrees. And so that's how you would describe city B, is that it seems to have temperatures that are either at one place or the other. And then the last question, from the data, which city has temperatures that are hardest to predict? Well, if you think about it, city A up here has temperatures that kind of cluster around this. You could predict that most temperatures will be in this range. City B, you could predict most temperatures would be here or here. But city C seems to have temperatures that can vary. They can pretty much be anywhere. So the answer to that would be city C is hardest to predict. So what have we learned? Well, you can just see from graphs like dot plots and histograms, you can easily see the center and how the data are vary or are spread out. And both of those things are really important things for statistics.